All right, side application of what we've been working with the three variable system of equations. Now that you know how to do that, you can do a problem kind of like this. So the problem goes like this. Find the equation of quadratic, or the quadratic equation that goes through 3 points, 1 comma 0, 2 comma 5, and 3 comma 12. Now before what you know now, you wouldn't be able to do a problem like this. There's just a little bit too many variables there. So let me walk you through an example of how to do this, and you'll have a couple practice problems today in the attendance task to see how you're doing with it, okay? So first off, quadratic equations are in this standard form. You might be familiar. It's ax squared plus bx plus c. We are trying to figure out what the a, the b, and the c are, so that if we typed in those numbers and graphed that parabola, it would go through those 3 points. Now to get started with this problem, what you're going to do is you're going to use each of these points to set up 3 equations to help you solve for a, b, and c. So let's get started with the first point. What you're going to do is you're going to plug the x and the y coordinate into this equation for x and y. So we're going to plug 0 in for y, and then we're going to plug 1 in for x. So it's going to go like this. 1 squared plus b times 1 plus c. Okay, now we're going to clean this up a little bit. So that one's going to be equals to 1 squared a would just be 1a plus 1b plus c. So there is our first equation. Now we're going to do it again for 2, 5. So here we go. 5 for y, 2 for x, and we're going to go ahead and square 2. So that's going to end up being 4. So that's going to be 4a plus 2b plus c. So there's our second equation. And then last but not least, let's do our third one. So let's do 12 for y equals a times 3 squared plus b times 3 plus c. And we're going to clean that up a little bit. So it's going to look like this. 12 equals, that's 9. So 9a plus 3b plus c, okay? So our 3 equations that we're going to use is 1, it's going to be 0 equals a plus b plus c, or 1a plus 1b plus c. Our second equation is going to be 5 equals 4a plus 2b plus c. And then last but not least, our last equation is going to be 12 equals 9a plus 3b plus c. Now sometimes these numbers are going to get really, really big, but don't be too concerned actually, because what you'll notice is a lot of these problems, c's are always going to pretty much stay c. So what I usually do for these problems is I like to, when I start this problem, I like to eliminate the c's first when I pair these equations up, and that makes my life just a tad bit easier. So what I'm going to do is I am going to take 1, and I'm going to multiply 2 by -1 so that the c's become opposite. So this is going to be 1 and 2. But again, I'm multiplying -1 by 2. So when I write 2 again, it's going to look a little different. So a is just going to be, or 1 is just going to be a plus b plus c. But when I multiply 2 by -1, it's going to end up being -5 equals -4a minus 2b minus c. Now I'm going to add those two together, and I'm going to get -5 equals -3a minus b, and then the c's cancel. So there's equation number 4 for you. And then I'm going to pair, let's just pair 2 and 3 together. Same as before, I'm going to keep 2 the same, but I am going to multiply 3 times -1. So I'm going to multiply 3 times -1 as well. So when I write down 2, it stays the same. But 3 is going to change all the things. So this is going to become -12. This is going to be -9a minus 3b, and then minus c. Okay? And I'm going to add those two together. This and this make -7. This and this make -5a. This plus this makes -b. And then the c's cancel. Okay? So this is going to be equation numero 5. All right. So when I look at 4 and 5, I'm going to stack those on top of each other now. I get negative 5 equals negative 3a minus b, and negative 7 equals negative 5a minus b. Okay. Now, to get variables opposite, I'm going to use elimination one more time. B's would probably be a good one, but one of them needs to be positive, one needs to be negative. So I'm just going to multiply this top guy by negative 1, and I'm just going to plug them right here below. So negative 1 times negative 5 is 5, negative 1 times negative 3 is positive 3, and then that's going to be a positive b, okay? And now I just need to add these two together. So this is going to be negative 2 equals negative 2a, and then the b's cancel. And what do you know? A is going to be pretty easy to solve for. Divide both sides by negative 2. And a is just going to be equal to 1. So we got our a. Now what I'm going to do is I'm going to go back to equation 4, and I'm going to plug a in to get b. So here we go. Negative 5 equals negative 3 times 1 minus b. That's negative 5 equals negative 3 minus b. I'm going to add 3 to both sides, so that's going to give me negative 2 equals negative b. And I'm going to, when I get a negative like this, I can think of it like a negative 1. I'm going to divide by negative 1 on both sides to get b by itself. So b is going to equal a positive 2. So I got a, I got b, and then last but not least, I can go back to one of my original equations to figure out what c is. So I'll just use this first equation. I'm going to replace all the information here. So it's going to be 0 equals 1 because a is 1, plus 2 because b is 2. And then I'm going to solve for c. So I'm going to go ahead and add these two together. I'll get 3 plus c. I'm going to subtract 3 to the other side, and that will be my c. So last but not least, I'm going to write my final equation. My final equation is going to be y equals a is 1, so 1x squared, plus 2, because that's my b, x plus, or in this case, sorry, minus 3, because that is my c. Whoopsie doopsie. But that would be what you would do to finish out the problem. So you'd figure out what a, what b, and what c are, and you would just rewrite it in the standard quadratic formula. So 1x squared plus 2x minus 3 would be the equation that goes through these 3 points. And if you want to check to see if you are correct, what you can do is plug those 3 points in to this equation and see if you actually get an equal statement. So let me just try that with 3, 12. So if I plug 12 in for y and 3 in for x, so it's going to be 3 squared plus 2 times 3 minus 3. You'll notice that this becomes 9 plus 6 minus 3, and that will indeed get you to 12 equals 12. So that checks out, and you can check it out with the other 3 points, but that would be how you could check your work, okay? So that is how you would do a problem like this using what we've been already learning with the 3 variable, 3 unknown type equations. So again, try out the attendance task. There will be 2 problems like this. Don't get too creeped out when the numbers get big. It should work itself out. And a quick hint, all the problems for A, B, and C should all be whole numbers. So if you're getting anything other than whole numbers, it's probably because you made a small mistake when you were eliminating at some stage, okay? So give it a shot, and then you guys have a wonderful break. I'll see you guys back in about a week, okay? See ya.